Hello, Algebra 2 people. This is your first Explain Everything. So the first thing we're going to do is find the equation of this line. So to find that equation, we have to find its slope using the 2 points given. So we subtract the y's over we subtract the x's. That gives you 15/3, which reduces to 5. Next, we want to actually come up with the equation of the line. So using y equals mx plus b, or point slope, it really doesn't matter. I can plug in a y value and plug in my corresponding x value and then solve for b. So 30 take away 10 gives me a b value of 20. So the equation is y equals 5x plus 20. Now the meaning, you have to look at the actual label. So this is all about renting a canoe, and we're looking at the cost over the amount of time. So the slope represents $5 per hour to rent the canoe. And the $20, which is our y-intercept, that you can call that sort of like a base fee, sort of like a service fee. All right, so that's the first problem. Now we're going to move on to our 3x3s, and we always want to look through all the equations. I also recommend labeling things, but that's me. So I notice in equation C there is no y value. So I'm going to eliminate y in A and B. So eliminate y. And I can do that by just adding A and B together. So what that would give me, actually it eliminated my x as well. So I end up with z equals 5 minus 4. So we got our z value right away. Wow, that was friendly. So since I have my z value, I can plug it into my equation C, which is 2x minus 1, because now I know z is 1, equals -3. So 2x, if I add 1 to both sides, is -2. So x is a -1. Awesome, we're almost done. So now we just need to solve for our y value. So I'm going to go back to equation A. We know that x is a -1. We're solving for y. 3 times z value is 1. And then combine our like terms. So 3 minus 1 is 2. And subtract 2 from both sides gives us a -6. And we write our final solution in an ordered pair, so that would be a -1, -6, and a +1. And that is the answer for that problem. All right, now let's look at number 3. So looking up and down, and again, this is purely judgmental, I'm going to eliminate x. I just think it looks like it would be the easiest to work off of. So I'm going to eliminate x, and I'm going to start by, let's see, the easiest is I'm going to add b and c. So if I add b and c together, x is going to go away, and I get 2y plus 5z equals 11. And we'll just kind of hang on to that equation. So we need another equation in both y and z, but I do have to still eliminate x. And I do need to bring in our first equation, equation A. So what I'm going to do is I'm going to go, let's say, 2 times A and add that to B. Let's see what that gives us. So 2 times A gives me 2x minus 6y minus 2z equals -18. And we write B exactly as it was. Plus y plus 2z equals 3. And now we can add those together. So x's go away. I have a -5y. My z seem to have gone away too. Equals -18 plus 3 is a -15. So that tells me that y is 3. Well, that was friendly. Okay, y is 3. I still need to solve for my other variables, but since I have a y up here, I can substitute the fact that y is 3 plus 5z equals 11. So 5z is going to be 11 minus 6, which is 5. So z is 1. And now I can take both of those and plug them into any of my original equations. I always like to plug it into A. It tends to be the easiest. So x, we don't know, minus 3 times 3 minus 1 equals negative 9. So x minus 9, so this is going to be minus 10. Add 10 to both sides. 10 minus 9 is 1. And so the solution for this is going to be 1, 3, 1. And that would be that final answer. All right, hopefully you're doing okay. So, this next one, let's see, which variable do we want to get rid of? Again, I noticed that there's no y in this third equation, so I'm going to go ahead and get rid of y in A and B. So I'm trying to eliminate y. So when I do A plus B, I get 2x, the y's go away, plus 3z equals 14. Hey, but wait a minute, that's what I have here. So obviously I have infinite solutions. And what I would like you to try and do is, that means we can't just plug in any old x, y, and z, but I can plug in any old x value, but everything else has a relationship. So I'm going to take this equation here, and I'm going to isolate my z term. So the first thing I'm going to do is subtract 2x to the other side, and then divide both sides by 3. So I know that z is 14 minus 2x over 3. My last thing is then to solve for y. So I'm going to use my equation A. X I'm going to leave as x. Y is what we want to solve for. For z, I'm now going to substitute in this lovely 14 minus 2x over 3, all equals 7. So since I don't really like fractions, I'm going to multiply everything by 3. So this becomes 3x plus 3y, 14 minus 2x, because that 3 will cancel, equals 21. Don't forget to distribute all the way. And we basically want to isolate this 3y. So everything's going to go to the other side. So 3x minus 2x, I have 3y plus 14 plus x equals 21. So 3y, subtract 14 from both sides, that's going to give you 7, and subtract x, and then we get rid of our 3. So y equals 7 minus x over 3. It's not pretty, but you don't actually have to substitute anything in, and that would be how we would write our final equation. X, 7 minus x over 3, 14 minus 2x over 3. And we're done. Whoop, we kind of encroached on the fourth problem. Luckily that one's going to be short. Because, let's see, if we look at this, who do we want to eliminate? I am going to choose z's, okay? Because that means, if I label these three equations, I'm going to add b and c together. Let's see what I get. I get negative 3x minus 3y, z's go away, gives me a negative 9. Okay, that's fine. I still need to get rid of z, so I'm going to combine 2 times c plus a. So 2 times c is minus 2x minus 2y plus 2z equals negative 20. A is going to be negative x minus y minus 2z equals 9. And when I add those together, I'm going to write my solution up here because I want to combine them. So I have a minus 3x minus 3y, z's go away, and that equals a negative 11. So what I'm going to end up getting here when I combine these is 0 equals, if I add these together, 0 equals negative 2, so that's a no solution. All right, so there are your 4x4s. Alrighty, so here is our second page, and we want to solve our baseball problem here. So what we're going to do is identify our variables. So we have reserved tickets are going to be $20 each, so we'll let X be reserved. And then we have field level tickets are $50 each, so Y is going to be the field. And lastly, we have the box seats that are $100 each, so Z will be the box seats. And we want to set our three equations. So one of them will be a quantity, one of them is going to be a value, and one of them is going to be a relationship. All right, so let's see what we have. You purchased 10 total tickets. That tells me how many tickets so I have X plus Y plus Z equals 10. Then they told us the total value of those 10 tickets is 370. So reserved are $20 each. The field are $50 each. Box tickets are expensive. They are $100 each, and you spent a total of $370 on those tickets. And then our last one, it's telling us that you have twice as many reserved tickets as field level tickets, okay? So twice as many. So here's my reserved, and here would be, so that's my reserved, and here's my field level, okay? In order to make these equal, to set up an equation, so remember this is your X and this is your Y, it's going to take, I'm going to have to multiply this one by 2 to make them equal. So 2 times Y is going to equal X. And there's your three equations. Now there's many different ways to go around and solve this. I'm going to use substitution just because we have one of our variables isolated. So into these two equations, I'm going to substitute wherever I see an X, 2Y. So I have 2y plus y plus z equals 10, which gives me 3y plus z equals 10. So there's one equation in just y and z. Into this other equation, I have 20 times 2y plus 50y, because I'm going to combine like terms. So that gives me 40 plus 50. So I'm going to have 90y plus 100z equals 370. And since everyone there has a 0, I'm just going to divide everything by 10. So I have one less 0 to worry about. All right, so these are the two equations in y and z that I want to solve for. So what I'm going to do is I'm going to take this top equation here and I'm going to multiply it, everything, by a -3. And we'll write it right underneath. Well, this is getting messy, so let me write this down here. We're going to rewrite these two equations. So multiplying by a -3 gives me -9y minus 3z equals a -30. And the lower one was 9y plus 10z equals 37. So when I add those together, y goes away, and I get 7z equals 7, which tells me z is 1. So I have one box seat. Now I'm ready to just back substitute. So back substituting, if z is 1, I know that 3y plus 1 equals 10. So 3y is 9, which means y is 3. And going all the way back, I have 10 tickets, so I have 4, which means x has to be 6. So to write your final answer, you want to write the solution in a meaningful way. So that means I have 6 reserved tickets. I have 3 field tickets and 1 box seat ticket. Okay? I hope that made sense. Okay, this part is multiple choice, which really, so the original graph here, f of x is just x. So this is just standing in here. So all of these are basically linear equations, and you really don't even need to know transformations in order to know what's going on here. So in this first one, notice I have a negative slope, but I'm crossing at a positive 3, so that would go with graph C. So a negative slope crossing at 1, and look, it has a steeper slope, a negative 3, that's going to go here. And by default, then, the one with a positive slope crossing at negative 1, that one is B. So nothing terribly interesting in that problem. All right, number 10, now you are going to have to graph. So I want to see the parent function and the transformation, and show some points. So the parent function here is y equals x squared. Now notice, unfortunately, this grid, I don't like that it went by 4s. We're going to change that because I think that's misleading. So this is 1, 2, 3, 4, 1, 2, 3, 4. Negative 1, negative 2. All right. So we know that the parent graph would be at 0, 0, 1, and 2, 4. That would be, and then use the symmetry. So that would be my parent graph. This graph is going to dilate vertically by a half, and then shift 1 right. So dilating by a half means all your y values are going to come down by half of whatever they are, but keep the same x value. And then all of those points move forward 1 point. So everything is going to move up. That point no longer exists. Okay, so that was down by a half. It went forward, and the 2 went. So your graph should look a little bit wider than the original. That's kind of hard to see, but that's kind of the idea. And your vertex should be here at 1, 0. Okay, this next one is just the equation of a line. So here's your y equals x. You don't really need transformations for this. We're just going to graph the equation of negative 2x plus 6. So here I'm going to keep my same. This is at 6, and I have a slope of negative 2. So down 2 over 1. Remember, each one of these is counting as 2, so I didn't change that. And this would be your graph. Hopefully you're better at hitting your points than I am. Okay, last one here, absolute value. That's our parent function. So remember, that's the v. There's the v. And this negative 3 means I'm going to reflect, and wherever this was, so if this was 2, 2, it gets multiplied by 3 in the y direction. So multiplying, because this is, remember, this is 2 and this is 2, so that's going to become 2, negative 6. So it's going to stretch it, but in the negative direction. I forgot to write. So this one, oh my goodness, okay. Reflect, that's the negative, over the x-axis. It's going to dilate vertically by 2 and up 6. This one, reflect over the x and dilate vertically by 3. Okay, all right, now the bottom problem. So we did one of these in class as well. So we are comparing Bubbles Car Wash to Soapy Car Wash. So Soapy Car Wash is given by this equation. X represents times the number of extras you get besides just your basic car wash. Bubbles is in the table. So notice plus 2, plus 2, plus 2, plus 3, plus 3. So that tells me that my slope here is 3/2. So remember, rise over run, the y over the x. So let's find Bubbles' equation. I'm going to just subtract 2 to get back to my intercept. So subtract 3 would give me this. So Bubbles has the equation y equals 3/2 x plus 6. And Soapy has the given equation y equals x plus 9. So the basic phi means we are comparing this, not the number of extras, but the basic fee without any extras. So which car charges more? That would be Soapy. Charges $3 more for the basic fee. Okay, how many extras must be chosen for their cost so that it doesn't matter which one you go to? So we set these two equations equal to each other, and you solve. So again, if you don't like fractions, although 3/2 isn't that bad, you could just multiply everything by 2. So 3x, because the 2's will cancel, plus 12 equals 2x plus 18. Subtract 2x from both sides, subtract 12. So it would require 6 extras in order for the two costs to be the same. All right, almost there. Okay, so we are going to write a function g whose graph represents the indicated transformation. So reflection in the x-axis. So what does that represent? That means taking whatever your f of x is and multiplying it by a -1 on the outside, because that's a vertical transformation. So I am multiplying, I'm going to substitute now what was my f of x. It was this. So when I do that, I get a new function. So the negatives cancel each other out. And you basically have now an absolute value that's going upwards rather than down. All right, so now this one, vertical dilation by 2. So that's going to be taking 2 times f of x. So let's do that first, because that's 2 times all of f of x. Remember, you have to distribute that. So that's going to give me 4x plus 10. Then we're going to translate 3 units up, which means on the outside we just add 3. So g of x is going to equal 4x plus, and we can combine the 10 and the 3. Okay, and then the last one, horizontal stretch by a factor of 3. So that's f of 1/3 x. Remember, what you write is the opposite of what it's doing. Now this means I substitute. So wherever I see an x, I substitute. So I'm substituting 1/3, and I have to simplify that. So both of these get squared. So that's 1/9 x squared. So g of x equals 1/9 x squared. Okay? And last bit. Okay, so these are going to be multiple choice. So they want you to determine, in this first one, what does x plus 2 do to the graph? So since it's inside, we know it's horizontal. Plus means it goes in the negative direction, which is to the left. So translation left by 2. Okay? The next one, it's on the outside of your absolute value, so we know that's a vertical dilation by exactly what it says. So it is, and since 6/5 is greater than 1, we call it a stretch. So that's going to be E. Now in 19 and 20, notice there's 2 different dilations, so you're going to have 2 different answers. So this 5 is outside, so it's a vertical stretch by 5. And then the inside, since it's -8, it goes to the right 8 units. So translate right 8 units. And then the last one, we have the 3/4, which is outside. 3/4 is less than 1, so that's a vertical shrink. And then we have the +3, which goes up 3 units. And that should be it. I hope this helped.